Okay, so where we left off was finishing number 37. We had V12. We were just about to do V3, so multiplying 6 by 1.626, we get 9.756 volts. Okay, we finished the most simplified circuit. We now step back. We had replaced R1 and R2 with R12. R1 and R2 are in parallel, and in parallel the voltage is the same. So V1 must be equal to V2, must be equal to V12 that replaced it. So this is going to be 15.244 volts, and this is going to be 15.244 volts. And now we multiply 15 ohms into that, or divide 15 ohms into that to get our I1, and it's going to be 1.016 or something like that amps, and this one's going to be 0.61 amps, and we're done. Okay, so those are the two from the textbook that were assigned on Thursday. I also asked you to do 3 on this sheet, complex circuit problems. So if we take a look at the first one, okay, and again the question always is, how do we simplify this? What do we put together? So total current leaves the power supply, flows through R1. It's going to be a series circuit, that means. Then when it gets to here, it splits. It actually splits into 3 sections. So these 3 are in parallel with each other, and so we can put them together. And then it comes back through R5, which is in series. So simplified, it's going to be R1 on the top, that hasn't changed. This is going to be R2, 3, 4, and this is going to be R5. Okay, so R1 was 4 ohms, and R5 was 6 ohms. Whoops, 5 was 6 ohms. And this is going to be R2, 3, 4, and the way we find it is they're in parallel with each other, so we have to do 1 over R2, 3, 4 is equal to 1 over R2 plus 1 over R3 plus 1 over R4. So 1 over R2, 3, 4 has to be 1 over 4 plus 1 over 6 plus 1 over 12. Common denominator is 12, so 3 over 12 plus 2 over 12 plus 1 over 12. That equals about 6 over 12, I think, which reduces to 1 over 2. So you can flip, and R2, 3, 4 is going to equal 2 ohms. So this is 2 ohms. And so now we can find our total, because they're all in series. So 4 plus 2 plus 6 ohms, that should be about 12 ohms. So we go to our chart. This is 12 ohms. This is 120 volts. That means this is 10 amps. This was 4 ohms, 4 ohms, 6 ohms, 12 ohms, 2 ohms, and 6 ohms. Okay, so we have everything filled in our chart across the bottom for our R's and up the side for our totals. So now we go to our most simplified circuit. We look at it and we say it's in series. And in series, the currents are the same. Now, not all the currents, so you're not going to fill in 10 ohms all the way across there. You're just going to fill it in for I1, I2, 3, 4, and I5, because those are the 3 that are in series. So 10 ohms for I1, we'll make this 40 volts when we finish that one. 10 ohms for I3, 4, 5. 10, I'm saying ohms, but I mean amps. 10 amps for I2, 3, 4. And 10 times 2 is 20 volts. And then in number 5, 10 ohms, 10 amps times 6 ohms, 60 volts. 60 and 20 and 40 give me back the 120, which we're supposed to get. So now we say, okay, so the 3 we replaced, 2, 3, and 4, they were in parallel. And in parallel, the voltages are the same. So V2, V3, and V4 must be equal to the V that replaced them, V234, which was 20 volts. So this is 20, this is 20, and this is 20. And now you just divide. You get 5 amps here, 620, 10 over 3, so 3 1/3 amps here, and 20 over 12, so 5 over 3, or 1 2/3 amps, and you're done. Okay, so that's number 1. Number 2 looks like this guy. So what do we put together first? Well, the total current leaves the power supply and flows through R1. We're going to eventually get to a series circuit. These two actually are in series, R2 and R3, but they're in parallel with R4 and R5. So in your first step, you're going to leave R1 where it is, and you can put together R2, 3, and then you can also put together separately R4, 5. Okay, so this will be R2, 3, this will be R4, 5, and R1 hasn't changed. So we go back and look, R2 and R3 are in series, and in series we can just add them up. And so when we add 2, 8, and 4, we get R2, 3 to be 12. R4 and R5, however, are in parallel, so we have to do 1 over. So 1 over R4, 5 will equal 1 over R4 plus 1 over R5. So 1 over R4, 5 equals 1 over 9 plus 1 over 18 ohms. So that should be 3 over 18, which of course reduces to 1 over 6. And so R4, 5 is equal to 6 ohms. Okay, so this is 6 ohms. Thing is, this is not fully simplified yet, because we have a series and we have 2 parallel. So we need to do one more step this time, and it's the first time where we've had to simplify a second time. So R1 still stays where it is, and then this becomes R2, 3, 4, 5. And it's very important to draw these, because as you work backwards, you're going to need to see them. So we need to find our 2, 3, 4, 5. They are in parallel. So it's going to be 1 over R2, 3 plus 1 over R4, 5. Okay, so 1 over 12 plus 1 over 6. Hopefully you know that that's 3 over 12. And 3 over 12 is 1 over 4. So 2, 3, 4, 5 should be equal to 4 ohms. Okay, 4 ohms. And now it's in series, and I can add them. 2 plus 4, I should get an R total of 6 ohms. So this is 6 ohms. My total was 18 volts, so I can get I total 3 amps. Filling in my other R's, this guy was 2, this guy was 8, 4, when we put them together, whoops, sorry, that gave us 12. Oh, I think, okay, no, sorry, I thought I missed a column. 9, 18, when we put those together, it was 6, and then this was 4. Okay, so now we look at our most simplified circuit. It's in series. In series, the I's are the same, so I1 should be equal to I2, 3, 4, 5 should be equal to I total. So this is going to be 3 amps, which is going to give me 6 volts here. And this one down here is going to be 3 amps, and that's going to give me 12 volts, and 12 and 6 gives me back the 18. Okay, then we take a step back. We replaced R2, 3 and R4, 5 with 2, 3, 4, 5. They were in parallel, so in parallel the voltage is the same, which means this should be the 12 volts, and this should be the 12 volts. I divide, I get 1 amp in this one, I get 2 amps in this one. I step back again, these guys